Okay, ladies and gentlemen, this is lesson video 2.7 on solving equations in one variable. The objectives are to solve equations involving fractions using both algebraic and graphical techniques and to identify extraneous solutions. Equations involving rational expressions or fractions are called rational equations. Every rational equation can be written in the following form here. If f of x and g of x are polynomial functions with no common factors, then the zeros of f of x are the solutions of the equation. Usually we do not have to put a rational expression in the form written above, so instead we can find the LCD of all the terms of the equation and multiply each side of the equation by this LCD. Sometimes the LCD contains variables, and if so, the resulting equation may have extraneous solutions that we're going to have to check for. Alright, so what we're going to be doing essentially is solving equations, rational equations, multiplying both sides of the equation by a variable, and then making sure we check for extraneous solutions because we multiplied both sides of an equation by a variable. Alright, so let's get started here with example 1. We want to solve x plus 3 over x equaling 4. So the LCD, alright, if this is x over 1, 3 over x, this is 4 over 1, so the LCD, the least common denominator, is going to be x. I'm going to multiply both sides of the equation by x. And then distribute, so I have x squared plus 3 equaling 4x, right? And I'm going to move the 4x over, so I have x squared minus 4x plus 3 equaling 0. And I can factor this quadratic equation. My signs are negative plus, so I'm going to have negative plus gives me negative negative, so x minus something. Alright, so I want factors of 3, that's sum to negative 4. So I'm going to plug in 3 and 1 here. Alright, that equals 0. So I have x equaling 3 and x equaling 1. Now, I multiplied both sides of this equation by a variable, so I have to check for extraneous solutions. So plug in 3 for x. So 3 plus 3 over 3 is 1, so I have 4 equals 4, so we're good here. Plug in 1, so I have 1 plus 3 over 1, which is 3, so that gives me 4 here, and 4 here, and so x equaling 1 will work. So no extraneous solutions in the first example. Example 2, alright. My LCD, again, that's the first thing that you wanna find here. It's just going to be x minus 4. So I'm multiplying both sides of the equation by that. So I'm going to have x minus 4 times x plus 1 over x minus 4, and that's going to equal 0 times x minus 4, which is just 0. So go ahead now and multiply x minus 4 times x, so I'm going to get x squared minus 4x, and then multiply x minus 4 by 1 over x minus 4, so I'm going to get a positive 1 there. Alright, and what you'll notice here is you're not going to be able to factor this, so we're going to have to plug this into the quadratic formula. So x squared minus 4x plus 1. X squared minus 4x plus 1 equals 0. Making sure I copied that right. Good. Alright, so the quadratic formula is x equaling negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I'm going to have x equaling negative 1 times negative 4 plus or minus negative 4 squared plus oops, minus what am I doing? Minus 4 times 1 times 1 all over 2 times 1. Alright, and so this is going to equal 4 plus or minus the square root of 12 all over 2. The square root of 12 can be broken up and written as the square root of 4 times the square root of 3. And so what I have to do now is just remember that divide both of these terms by 2. So I have x equaling 4 divided by 2, which is 2. Alright, and then the square root of 4, that's 2. So 2 divided by 2 is 1. So plus or minus the square root of 3 is what I'm going to be left with. Plug this into your calculator and you get x approximately being 0.268 and x approximately 3.732. Now, to check these, what I would do is graph this, find the zeros, and when you do that, you'll see that these are going to be the zeros. So, in example 2, we don't have any extraneous solutions either. Alright, example 3. Will we have extraneous solutions in this one? We shall see. Alright, so the first thing, find the LCD. And what you'll notice here is x squared minus 4x plus 3. We factored that in example 1. We factored that and got x minus 3 times x minus 1. So that's going to be what my LCD is. So x minus 3 times x minus 1. So I'm going to have to multiply both sides of this equation by that. So got to write small. So x minus 3 times x minus 1 times 2x over x minus 1 plus 1 over x minus 3, and that's going to equal x minus 3 times x minus 1 times 2 over x minus 3 times x minus 1. Alright, this right here, that part is just this part here. Okay, so now I have to multiply x minus 3 times x minus 1 times this first term here. So the x minus 1's cancel, so I'm left with 2x times x minus 3. Okay, multiply all this by the second term, so the x minus 3's cancel, so I'm just left with a positive x minus 1. Alright, and this is going to equal, well, my x minus 3's cancel, my x minus 1's cancel, so 2 is the only thing that's left. Alright, distribute the 2x, so I have 2x squared minus 6x plus x minus 1 equaling 2. Alright, so let's subtract 2 from both sides, get it on the same side of the equal sign, so do minus 2 equaling 0. Alright, so I have 2x squared and a negative 5x minus 3 equaling 0. Okay, so what I'm going to have to do here is, let's go ahead and solve this by factoring by grouping. And when we factor by grouping, remember we want to find factors of my a times c. Alright, that's sum to my b. Alright, so in this case I want factors of negative 6, 2 times negative 3. That's sum to negative 5. Alright, and so negative 6 and 1 are going to be those factors. And it's those factors, negative 6 and 1, that I rewrite this middle term, this negative 5x. So I'm going to have 2x squared. I ask myself, which goes better with the 2x squared, the x or the negative 6x? And so the answer is going to be the negative 6x. Alright, we're going to add x minus 3 then, and that all equals 0. Now we're going to, like I said, we're factoring by grouping, so we're going to put parentheses around the first two terms, and then parentheses around the last two terms here, and then we're going to factor out here a 2x, and so I'm left with x minus 3, and then I just have an x minus 3 here. Alright, so if you do this right, these things right here match up. And before I go any further, I want to make sure that I include a 1 here. So this is 1 times x minus 3. And that's important because I take the 2x, I take what's out in front, the 2x and the positive 1, and I set that equal to 0, along with the x minus 3 equaling 0. So x is going to equal negative 1/2, and x equals 3 here. All right, and so we want to check for extraneous solutions. So let's check x equaling 3. Now, if I plug in 3 for x here, notice that I'm going to be dividing by 0. All right, no, we can't do that. So x equaling 3, that's going to be an extraneous solution. And if you were to plug in x equaling negative 1/2 into this, all right, you would see that this would be a solution. So x equaling 1/2 is my solution. X equaling 3 is the extraneous solution. Last example here. Solve this equation. All right. So first thing, find the LCD. We can kind of rewrite this, x squared plus 2x, we can rewrite that as x times, we can factor out an x times x plus 2. Alright, so this works out good again here because we have an x plus 2, and then an x times x plus 2. So this is going to be the LCD. So I'm going to multiply both sides of the equation by this. So x times x plus 2 times x minus 3 over x plus 3 over x plus 2 plus 6 over, and I'm just going to rewrite this as how I factored it here. Oops, didn't need to do that. So x times x plus 2. And that equals 0 times x plus 2, so 0. Alright, so now we have to multiply x times x plus 2 to each of these terms. Alright, so my x's here and here will cancel. Alright, so I'm going to be left with x plus 2 times x minus 3. Alright, my x's plus 2 cancel in the next one, so I'm just left with plus 3x. And then the final one, both the top and the bottom here cancel, so I'm just left with positive 6. And all that equals 0. I'm going to FOIL here, so x squared minus 3x plus 2x minus 6, and then I'm going to add 3x plus 6, and that's all going to equal 0. So now what's left is just to combine like terms. So where can I put this? Let's try and squeeze it in down here. So I have x squared, and I have a negative 3x plus 2x, so that's a negative x, plus 3x, so plus 2x. So this is gone, 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 and gone. A negative 6 plus 6, well, those are goners too. Alright, so I have x squared plus 2x equaling 0. Alright, and so I'm going to have x, erase this. So I have x squared plus 2x equaling 0. So factor out an x, so x times x plus 2. That's my LCD here. Alright, so x is going to equal 0 and x is going to equal negative 2. Now I want to check for extraneous solutions, so I'm going to plug in 0 for x. Notice right away that I would be dividing by 0, so x equaling 0 is extraneous. Alright, plug in negative 2 for x then, and if I were to plug it in here, I'd have negative 2 plus 2. Again, I would be dividing by 0. Alright, and so in example 4, I would not have any real solutions. So no real come on, eraser. No real solutions for the last one. Alright, so this wraps up 2.7. Like I said, it shouldn't be anything too bad here, just so it gets a little bit long with some of the problems. There's one more application problem that we're going to be doing in this lesson, but other than that, pretty easy lesson for the most part.